Okay, thank you. As we spoke about before, and we've been speaking about for the last few years, an algebraic expression gives a general rule or a relationship between variables. Okay, that's the strength of it. It gives you a general way of saying something. So when you want a specific value, specific sets of value, all you have to do is substitute in those values, and then you get your result. Okay, so you substitute the numbers or different values into the expression, and you get the result you want for that combination of variables, or for the combination of numbers. So basically that's it. So all you're doing is saying that, for example, you have an expression like this, CTX. Okay, what does this equal? If C equals a specific value, T equals a specific value, X equals a specific value. Right, so what you're doing is instead of having the algebraic symbols, you actually write in the numbers. You substitute the numbers in for the symbols, perform the operation, and then you find the specific result. Okay? So if we have a look at this one, the example is substitute the value C equals 1.3, T equals 8, X equals 4.3 into the following expressions. So this one is CTX. So it's all three multiplied together. So what we get is 1.3 times 8 times 4.3, and that is equal to, find a common please, Italian. Find it, please. 1.3 times 8 times 4.3. Go. Get it? What is it? 44.72. Alright, so all we're saying is, for the specific value that we have, that is the value. If C is 1.3, if T is 8, if X is 4.3, that's what CTX is. It could be a whole different thing. It will be a whole different thing if the combination is different. Okay, so that's the idea of substitution. You substitute the values in for that specific thing. Right? 1 minus Cx over T minus 1. 1 minus Cx over T minus 1. Again, we substitute. Instead of writing C, we write 1.3, T, etc. So it's 1 minus 1.3 times X, which is 4.3, over T, which is 8, minus 1. Okay? So please find this for McLaughlin. 1 minus 1.3 times 4.3 over 8 minus 1. Just to check the 1. Yeah, so negative 1.57. Okay, the 2 decimal places. Okay, so again, all we're doing is substituting the values in. Hey, any questions? You all familiar with this? Go through the exercise quickly, and I'm hoping that I'm going to do something else this period. Okay, the square root of C times T minus X squared. Right, so if I remind myself what these values are. Okay, so I've got the square root of C is 1.3, extend that, times T, which is 8, minus 4.3, it's X, 4.3 squared, equals, what do I get, Sean? Square root of 1.3 times 8, minus 4.3 squared. should be minus 15.27. Minus 15.27 is to 2 decimal places. So make sure that this is outside of the brackets.
Yeah, I put brackets in on that.
Is it square 4.2?
That was
4.3 squared.
Oh, I did 1.3.
Okay, so exercise 2.8, 2.03, sorry, questions 1 to 8. Listen up. So brackets are used as grouping symbols. Okay, so you can have all sorts of brackets when you have algebraic expressions. You can have these sort of brackets, you can have square brackets, you can have curly brackets, you can have all sorts of any shape you want, really. So there's brackets, but they do the same thing. And in the calculator, there's only one type, but they're all grouping things in different levels. That's the idea of a set of brackets. We can expand brackets. Oh, it's going to stop down and listen to this. You can expand brackets by multiplying the factor outside the brackets, which in this case here is 4, with each term inside the brackets. Now, I will do it a couple of times how I've been doing it, but I'm going to stop doing this whole arrow thing a little more, okay? I'm not going to do this very often anymore. You know how I was doing this before? Okay, I'm going to stop doing that soon. Because the assumption is going to be again that you just understand that that's what I'm doing. Everything inside the brackets has to be multiplied. Each term inside the bracket has to be multiplied by what's outside the bracket. That's the whole idea of expanding. And as we talk about factorizing later, factorizing and expanding are opposites. Factorize to get brackets in the expression, and you expand to get rid of the brackets. Okay? So basically, if you follow through these examples, what we have to do is multiply the 4 with the x and with the 1. So this is going to become 4x plus 4. Good. 4x plus 4. Please don't do this. It is not 4x plus 1. It is not 4x plus 1. It's 4x plus 4. Because you have to multiply the 4 with both terms inside the bracket. Okay? What about this next one? 5, 1 minus 2x. 5 times 1 is 5. 5 times minus 2x. Remember that the minus 2x, the negative sign goes with that 2x. Think of the terms as just individual packages. The symbols between the terms will look after themselves if you do it correctly. Okay, if it's going to be negative, the negative sign will be part of that term, and which means it's going to be something minus something. So what's 5 times minus 2x? Minus 10x. So it's just simply 5 minus 10x. And you see that the term is minus 10x, but the operation between them is also minus. Okay, so think of it as individual terms as the expander. This one is 5 minus 10x. This one here, if we have a look, we've got minus 4, then 3x, and then minus 3. What's minus 4 times 3x? Minus 12x. And then what's minus 4 times minus 3? Huh? Yeah, so it's just plus 12. Just write it as you see. And so the operation is dealt with. Or you can write it as it also equals 12 minus 12x, which is nice and neat. You got this sort of, you don't have any negatives sticking out the front. It's nice and neat, 12 minus 12x. Are there any questions? So, thinking this is familiar. Good with this? Actually, ask me if you do have questions after. Feel free to ask me. Next one. 5x, 4 minus x. Eleanor. There's nothing above us. No. Okay? Brock, what's this one? 20x. Good. 20x minus 5x squared. multiplied the terms, the term on the outside, the factor on the outside, with each term on the inside. 20x minus 5x squared. Now this one we need to take a couple of steps. We need to expand both sets of brackets, and then we can simplify. So Dan, can you expand the first set of brackets? Yeah, 12x. Six times 2x is 12x. 6 times minus 3 is minus 18. Okay? Now, and you can expand the second set of brackets. Remember, there's a negative 4 here. Yeah. It's negative 4 times positive 3. Well, right. Yeah. 4 times 3 is then, so it's going to be minus 12. Alright, so can you simplify this expression for me? Yep. Think about it. You've got minus 18 minus 12. Minus 18 minus 12. You're starting at negative 18, you're moving down 12 spots. It does mean negative. Okay, 8x because 12x minus 4x, 18 minus 18x minus 12x. You always have to take into account the sign that comes before the term. It's part of the term. You always have to consider that. Minus 18 minus 12 is minus 30. You're starting at negative 18, you're moving down 12 spots, you end up at negative 30. Okay? So that's our simplified version, and we can factorize that if we wanted to. The final one, 6x bracket 2x plus 2 plus x bracket 4 minus 5x. First set of brackets. Courtney, could you expand the first set of brackets, please? Yeah, good. 12x squared plus 12x. And then Rebecca, can you do the second set? Yeah. Good. Minus 5x squared. Excellent. And then, finally, Josh, can you simplify this for me? Let's think about it. Which are the like terms? Which are the like terms? Good. Yeah. So how many lots of x squared do we have? Good. 7x squared. And then we have 12x plus 4x, which is good. Plus 16x. And that's as simple as you can get. You can factorize that again, but that's as simple as we're going to get. Good. So that is how we expand and simplify. Alright, always take into account the sign before the term. If you think of it like that, you can stop worrying about what symbol comes between the terms. They look after themselves. Just think of it as just a negative 3, which means something minus something. But it's just negative something term. Okay, so there. So grin on your face. Like that. Good? Good. Alright? We're good? Alright, so 2.04, 1 to 6, third column.